Alright, so let's begin with another question, and this one states that we have to find the area, the exact area by the way, of region R, and this is region R over here. And what is the curve? It is y is equal to sin x cos 2x for this interval right here. So first things first, we need to determine what the limits are. So I will just determine these two things right here, and these are just the x-intercepts of this curve right here. So what do we do to find x-intercepts? We just equate it by 0 because y is 0 in that place. So sin x cos 2x should equal to 0, which states that either sin x is equal to 0 or cos 2x is equal to 0. So when sin x is equal to 0, we know that the answer is 0 or pi. And we can already see that that is in fact the x-intercept of these 2 points, but we are looking for these 2 points. So we will refer to cos 2x is equal to 0, which would be 2x should equal to pi by 2, comma 3 pi by 2. Therefore, our x should equal to pi by 4, comma 3 pi by 4. So we can label this as pi by 4 and 3 pi by 4. And I'll just erase this working so I can solve the integral right here. So now for the integral, we will write this as pi by 4, 3 pi by 4 sin x cos 2x. Now before proceeding, I would like you all to look at this rule, power rule over here, which works for any function as long as you have a function raised to the power of any n. But if you have its derivative outside, what you can do is you can just apply this power rule right here. Now I'll give you an example. For example, you have x squared, right? Now what is the derivative of x, the function inside? I will just rewrite this like this. Now what is its derivative? It's 1, right? And 1 is available outside of the bracket, which means power rule is applicable here, and all of you know that the answer for this would be x cubed divided by 3 plus c. Now, what if I said that we have another question such as sin squared x cos x? Now the good thing about this rule over here is that this can be used for this expression right here as well. Let me elaborate how. So you can write this as sin x whole squared cos x. Now if you notice, this f of x, this is basically sin x, right? And its derivative, which is cos x, is available outside. And now even if we had any power over here, it wouldn't matter. We just had to add 1 and apply power rule to that. Well, over here we have sin squared x. So our answer over here should be f of x whole power n plus 1, which means sin x whole power n plus 1. What is n? N is 2. So 2 plus 1 divided by 2 plus 1. And that would be our answer. Now, this could have been possible even if it was sin power 8x cos x, because at the end of the day, we have sin x inside the bracket and its derivative is outside. So we can apply a power rule here, and it would be sin power 9x divided by 9 plus c. So this is a short concept you need to know in order to solve this integral right here. So let's proceed with this integral again. Now over here, how will we convert this into the form that I was showing you before showing this integral? Now for that, what you need to do is you need to substitute something instead of cos 2x. Now what will you substitute? Well, I think the best thing to do here is to substitute 2 cos squared x minus 1, which you can clearly see from MF19. Therefore this would become 2 cos squared x sin x minus sin x, right? Because I expanded the brackets. Now I can just take 2 as common and write this as cos x whole squared sin x minus integral of sin x, right? It wouldn't be a problem. Now if you notice, this is the same as the power rule which we discussed right now, which was f of x whole power n plus 1, and f derivative of x of integral should be equal to f of x, oh this was n by the way, f of x n plus 1 divided by n plus 1. So this can be applied over here as well. Now you might be thinking, but wait, even though this is f of x, its derivative outside should be minus sin x, but we do not have a minus sign over here. Well, for that we can just literally introduce it ourselves like this, minus minus, because at the end of the day both of these cancel out. But this is essential in order to obtain this result over here, right? So now, since we have a function and its derivative is in fact outside, what we can do is we can apply the power rule over here. That's exactly what we're going to do. Minus 2 cos of 3x divided by 3 minus, what is integral of sin x? It is in fact minus cos x. Now I can rewrite this, all of this in one bracket, and that's what I'm going to do. Minus 2 cos cube x divided by 3 plus cos of x, with the limits being pi by 4 to 3 pi by 4. Now, one thing that you can check from your calculator is that cos of 3 pi by 4 is, if I recall correctly, minus 1 over square root of 2 or minus square root of 2 divided by 2. Both of them are the same thing. And cos of pi by 4 is 1 over square root of 2 or square root of 2 divided by 2. Both of them are in fact the same thing. So yeah, let's just substitute that real quick. And you cannot find a numerical answer because remember, the question said find the exact area, and that's why we are going to do the manual working, which is minus 2 by 3. And yeah, we're going to substitute minus 1 over square root of 2 cube plus, over here we'll just write minus 1 over square root of 2 and then minus this, which will be minus 2 by 3, 1 over square root of 2 whole cube plus 1 over square root of 2. All right, now let's just solve this decently. So this should be minus and minus will in fact cancel out. So this should be plus 2 over 3. And over here it will be 1 over 2 square root of 2. You can either do this by calculation on calculator or your mental math. And over here this will be minus 1 over square root of 2. This will be minus 2 by 3, 1 over 2 square root of 2 plus 1 over square root of 2. Now what we are going to do next is cancel out this and this, this and this, which leaves us with 1 over 3 square root of 2 minus 1 over square root of 2. And this will become plus because minus minus is plus. So 1 over 3 square root of 2 plus, and this will become minus 1 over square root of 2. All right. So yeah, let's just do some arithmetic here. And this will become 2 over 3 square root of 2 minus, this will become 2 over square root of 2. Fine. And yeah, now if you move on even a bit further and take LCM, what we're going to get is we're going to get 2 minus 6 over 3 square root of 2, which is in fact minus 4 over 3 square root of 2. And I'm just going to put a modulus here because we're finding this area right here, but obviously the integral is going to give us an answer in negative. But since the question required you to find the area itself, we're just going to put a modulus here. So our final answer will be 4 over 3 square root of 2. Fine, because that's the numerical magnitude of area. And if I had to calculate its exact value, that will be 0.942. So that's how you solve this integral. You just needed to know this concept right here of power rule, which I explained. And you also needed to convert this into this form. Now, why did I convert this into this form specifically? It's because I knew this concept right here. And I knew that if I could get, for example, sine squared x with cos x, that would make my life a lot easier compared to if I converted cos 2x into, let's say, 1 minus 2 sine squared x. That would be a lot more problematic.